Hello. This week we're going to look at another statistical tool based on what we've been learning for the prior weeks. We're going to learn a topic called hypothesis testing. Hypothesis testing is a very important tool that we use in statistics. I want to start by kind of giving you a simple scenario. Haven't you watched a movie or not even a movie? Have you watched a TV show or seen an ad where a company will make some big claims, right? And you wonder if that is true, right? So, for example, I believe we said that if you take two of their tablets, your headache will go away for at least 6 hours, right? Or an Apple phone, we say, or Apple Watch, we say that it can, if once fully charged, it can give you up to 8 hours or 12 hours or 2 days of service without any issue. Those are claims that are made by various people or various organizations or various companies. And so sometimes we want to test to see if those claims are true, right? A car company might say that you get 100 miles per gallon or 50 miles per gallon, right? But how true is that? And so sometimes what we tend to do is we want to see if that claim is true. And so hypothesis testing is actually pretty straightforward. So let's use a simple example. Let's say, and please don't make fun of my drawing, let's say that a car company, right? Let's say Volvo says that their brand new XC70 gives you 60 miles per gallon, right? Now, remember, Volvo is the one that owns the car, so they are the population, right? They control the population. They have all the cars that are made, so maybe 10,000, maybe 100,000 cars, right? Okay. Now, imagine that you work for a company that writes reviews for cars, right? And you heard this and you're like, 60 miles per gallon? I don't think that's true. Now, remember, that's the claim that the company makes, right? That they get 60 miles per gallon. And so you can test to see if this claim is true. To do that, you now go to a Volvo dealership and you now buy or you lease 30 of the cars, right? And then you get 30 of your friends to drive the cars. And once they drive the cars, they tell you how many miles per gallon they get, right? And you log in those miles. So maybe one says we got 64, second one says we got 53, right? You get all those numbers. And so once you get that numbers, your goal is to see if this is true, right? So this is an example of a population mean or population parameter, right? A claim made by the company because they own the whole car, so that's population. Now, let's say you get yours to be 54 miles per gallon after taking the average of 30 cars, right? Now, the question now is, can we say that what the company said is true or false? And so before you start to look at this in hypothesis testing, we set up a claim, right? We set up what we're trying to test, right? We're testing to see what the company said is true. And so now, once we do that, we're going to conclude if what the company said is true or false. Now, remember, this goes back to our basic understanding of normal distribution, right? So what I mean by that is the company's claim is the mean, right? So that's 60. Now you get yours as 54, right? This is what you had, miles per gallon. Now the question now is this value far enough for us to reject this 60 miles per gallon and say it's not true? Or is this distance so close that we can say, you know what, it's not too far off. So maybe what the company is saying is true, right? Because sometimes if I don't have sufficient evidence to disprove, then I might as well go with what they're saying until I can prove otherwise. Now, what I just went through with you using the car is a clear example of hypothesis testing. Now, hypothesis testing goes through about 6 to 7 steps. And what I want to do today is to walk you through all those steps, right? So let's start with the first step. The first step with hypothesis testing is, before I want to start a test, I need to set some guidelines or tell myself what I'm trying to do, right? And so there are two things that we can do, right? We set up our hypothesis, and we have two options. One is called the null hypothesis, known as the H sub O, and the other one is called the alternate hypothesis. It's known as the H sub A. So we have the H sub O and H sub A. And I'll explain the two of them because that's the first step we take. All right, we set up what we want to do. Now, H sub O is actually what we call a statistical hypothesis, and it contains a statement of equality. So what does that mean? That means that when I'm setting up a hypothesis, a null hypothesis, it's always going to be about equality. So it's going to be greater or equal to, less or equal to, or equal sign. And remember, you are trying to see if the claim is correct, right? And so you're testing, you want to test what the population parameter is. So it's always going to be about the population parameter. In most cases, that will be the population mean. So H sub O or H sub A will always be about the population parameter. So by setting up the null hypothesis, the conclusion is that if we don't agree with the null hypothesis, then we'll have to agree with the alternate hypothesis. So this is always known as the complement. And the reason why it's called a complement is that if it's not a null, then it's going to be the alternate. And so it's always going to be the opposite. So you can see this says greater or equal to. So the opposite of greater or equal to is what? Less than. The opposite of less or equal to is what? Greater than. And the opposite of equal to is what? Not equal to. So whenever you're doing your hypothesis testing, one of this has to be true. It's either going to be your null, which is H sub O, or it's going to be your alternate hypothesis, which is H sub A. So a simple way to write this is, remember when we did example about the car, right? We said the car was 60 miles per gallon. Now, let's write that in that form. In that form, remember we have to write it. So H sub O would say that the mean miles per gallon that you get for your car, which is what Volvo is saying, is what? 60 miles per gallon. But I don't really think it's true. So I disagree with them, right? But I have to test to see if it's true. So I would say, okay, mine is not equal to what? 60 miles per gallon. So you can see in this case, we have two scenarios. Either what the company is saying is true, and we can prove we don't have enough evidence to prove that it's not true, or what they're saying is false because we have enough evidence to prove they're false. But before I start, I have to set up this. And this is step one. Now, so that's one way we set it up. Now, if they had said that they get more than or equal to 60 miles per gallon, we can set it in three different ways. We can say that H sub O would be greater or equal to 60 miles per gallon. And the opposite would be H sub A is what? Less than 60 miles per gallon. The third way can be is what? Less or equal to 60 miles per gallon. And the opposite would be what? Greater than 60 miles per gallon. So whatever the question you're going to be solving, you're going to have three of these. One of these scenarios is going to be true. Either going to be the first one where you have equal to and not equal to, or the second one where you have greater or equal to and less than, or the third one when you have less and equal to and greater than. You see, in this case, the way it's set up is that if it's not this, then by default, it becomes H sub A, right? And so we're going to use this to solve our questions. So what we've done here is set up step one. Okay. So that is our step one. Now, we now go to our step two, right? Because I said there's about 6 steps that we're going to go through this. But once you understand the concept, this is actually easy, right? Now, the second step is what we call our level of significance, right? Our level of significance is also denoted by alpha. Now, I want to explain what the level of significance is. The level of significance is basically looking at the risk that you're willing to take, the level of risk you're willing to take. And this is something that's common in many businesses. So a business will say that, hey, we can take up to 5% level of significance. What they're saying here is that if they produce a product, right, or products, if they do a sample of that product to check what the quality is, as long as the error in the products is 5% or less, then the product is still good to ship. But if the error is above 5%, then they will have to kind of look back and see how to fix the problem. Every company has a level of error. That's why when you and your friends go out to go buy a TV, you can buy the same TV, while yours would last 10 years, theirs might last 2 days, right? That's because they probably bought one of the defective ones. And so the companies always want to have a percent of defective that they're willing to live with. Companies that have very low level of significance means that they are willing to take less risk, which is good because then they have better products. But companies that have a high level of significance, what you notice is that they have more errors in their products. And so that's why you see a company like Apple will have better products than maybe Samsung or other companies, because they make sure that the error is very low, right? That's what the level of significance is. Now, this is important in doing your research because it allows you to decide what amount of error you're willing or risk you're willing to take when you do your research. Now, a simple way to look at this is that while it's a good measure, right, level of significance also has its risk. It allows for a couple of mistakes to be made. And I'll give you a simple example. There are 2 key errors that are made with level of significance. The errors are known as type 1 error, and the second one is known as type 2 error. Okay? Now, these errors are common in depending on what the company is trying to do. So let me explain how the type 1 error is. Type 1 error is when you reject the null when it's true. Right? So imagine saying that something is wrong when it's actually true. So somebody comes to your hospital and they say, oh, do I have a headache? You check, you make a mistake in the check-in, and then you tell them, oh, you're fine, when actually they are not fine, right? And so that's what type 1 error is. But I will give you a simple example. Imagine that a company makes 500 products, right? And the company has agreed beforehand that the risk they're willing to take, that the error they're willing to take, right, is 5%. What it means is that if there's an error rate of 5% or less, they will still ship those products to customers because that's a low error. But if the error is above 5%, then they need to go in-house and reproduce those goods, check on every other products because it's defective, which is expensive for them, right? Now, so they cannot check the whole 500 products. Nobody does. What they do is they sample. So let's say they sample, right, 100 of those products. And then out of that 100 products, they found 10 had errors, right? Now, you all know that 10 out of 100 is 10%. So they will now say, oh my God, we have a high level of error. Let's go ahead and let's say destroy the remaining ones, right? Let's just go extreme. Now, the problem here is supposing that almost every one of the remaining 400, because remember they sampled 100, right? What if the remaining 400 were all good, almost all were good, but this 100 were the bad ones or had the bad ones, and so the sampling was done incorrectly. So what you've done here is you rejected this when it's actually true, right? That's an error that is made in a type 1 error. A type 2 error is actually not rejecting when you refuse to reject 8 of O when it's false, right? This is usually called a beta error, right? This one is alpha. But type 2 error is actually common too, is something is false, but you don't know, right? And you fail to reject it, right? So a common example of this is, even if let's use the same example we have here. But in this case, when they took a sample of 100, they only found 2 to be bad, right? And that's 2%. And so the company says, oh my God, that's amazing, right? We got only 2% bad, and our threshold was 5%. So now they decide to ship the remaining 400, or I mean, all the products, right? The whole 500. Now, here's the problem with that. Supposing, just bear with me, supposing that all the remaining 400 were actually bad, but this 100 was the only good batch, and somebody just made a bad sampling and picked all the 100 good ones, and we only found 2 bad out of those 100. So what problem now is that you're going to ship 500 mostly bad products to customers because you did a poor sampling. And so in this case, you did not reject a null when it's what? False. So you can see that in this both scenarios, the level of significance has played a huge role in affecting our results, right? That is step 2. All right. Now let's move to step 3. Now, in most cases, in step 2, I'll give you the level of significance, but there's also a small chance that you may not be giving that for your final project, but then you have to choose your own number. So that's not a big deal, right? You select the percentage you want, right? And you give a reason for selecting that, right? Level of significance tends to be, usually it's 1%, 5%. Extreme is 10%, right? Companies want it to be less than 5%. And so the common trend you see is 5%. All right. So step 3 is we're going to decide on what type of test you want to do. So there are 3 types of tests. It's either you have a left tail test, and we're going to solve a question where we're going to take this from step 1 all the way to step 6, and you see how it's done. So you either have what we call a left tail test, and a left tail test looks like this, right? So you can see here is left tail. And if you remember when we did the matrix distribution, when you have something like this, a scenario where you shade to the left, right? It's a left tail test, and usually you do that when you have values to the left and it's for less than, right? So when HA has the less than sign, it's a left tail test. So something to remember, right? So when HA or H sub A has a less than sign, so let me show you here. So you can see in this example here, this will be a left tailed test, right? Because it has a less than sign here. Now, for a right tail test, remember the right tail test will look like this, right? So this is greater than, right? You can see usually it's greater than, so it's moving to the right of your normal call. So usually when HA has a greater than sign, it's called a right tail test. So this, for example, will be a right tail test, right? Third, when you have a scenario, you can see in this case, you can see the values are on both sides, right? This is an example of a two-tailed test. And we're going to do a couple of them in class so you get comfortable with them. for two-tailed test, we know the test is a two-tailed test when h of A has the not equal to sign. So let me rephrase again. When h of A has the less than sign, we know it's a left tail test. When h of A has the greater than sign, then we know it's a right tail test. When h of A has the not equal to sign, then we know this is a two-tailed test. Right? Okay. Now let's move to step 4. You got a whole lot of steps to go. But once you understand the steps, solving the questions actually is not as difficult as it seems. You just follow the steps and you get your answer pretty easy, right? So let's look at step 4. Now, step 4 is what we call the test statistic. So what we're doing here is we're trying to determine the sample information, right, from the population, and we're using that to find whether we want to reject what the null is or not, right? But also what the z-value does, or the test stat, what the test stat also does is it really provides you an insight to show you how far or how close you are from what the population parameter is. Remember, right? At the end of the day, what happens is if a company is saying, let's say, for example, let's go back to our Volvo. If Volvo was saying that it's 60 miles per gallon, what we would do is this becomes, right, the mean, right? That becomes 0 for z values, right? Now, if I said mine was 54 miles per gallon, what happens is the test stat will help tell me where 54 stands, right? It will tell me if it's -1 or if it's -2, and that tells me how far or how close I am to what the mean is. Now, the further I am from what Volvo is saying, the likelihood I will reject what Volvo is saying. The closer I am to what Volvo is saying, the more likely we're going to say, you know what, we don't have enough evidence to prove that it's wrong, so we're going to go with what Volvo says. That's where we fail to reject A sub O. So the test statistic is helping us converting our values to a z value, right? Converting the difference or the distance between what I got and what the company got. And from there, we can see how close or how far we are from what the company is saying, right? And so the test stat is actually an indicator of such. Now, when you have, and we'll talk about this in detail, when you have population standard deviation given, and when your number sample size is 30 or more, we tend to use z values for test stats, right? And so the formula is your sample mean minus your population mean, right? You can see this is trying to show distance, right? Sample mean is what I got, right? So in my case, I got 54. Population mean is what Volvo said, which is 60, right? This is to show how different we are. And so you divide that by the standard error. And the standard error, if you remember, is standard deviation over what? The square root of what? 30. So in our case, whatever our standard deviation is, right? Let's assume that, let's use something simple. Let's say it was 5. We'll now divide that by what? 30. Oh, sorry, this is my bad. This is supposed to be divided by the square root of n, right? So let me see if I can erase that and fix that real quick, and then we can continue. So that would be standard deviation over the square root of what n. Remember, this is your standard error, right? You remember when we did CLT. So this result actually comes in the form of a z value, and it's the difference. It's from the sample, right? This result is from the sample. It shows how far my result is from what the company says, right? And this will give me that value. Now, once you get that value, right, there are 2 ways to solve the question from that. You can go on and start using p-value, which you all know, we've done that through normal distribution, or you can go ahead and solve the question using critical value. Right? Both of these methods, this is step 5. Now they've done step 4, which is the hard part. Both of these methods can take you to the promised land. And whichever one you want to use is fine. And so I'm going to walk you through the p-value steps, and then I'm going to walk you through the critical value, and you're going to see how similar they are, and you're going to decide which one you want to use in the exam or in your classwork. And I prefer the critical value, but any one you use is actually fine, right? And it can give you your results. So let me explore the p-value. You know, right? The p-value is just, it basically is the probability value, right? So it's a probability of obtaining a sample statistic, right? And that value is really tiny, or the extreme value that it can be from the sample. So you compare that to your level of significance. Remember, your level of significance is the highest risk you're willing to take, right? So you compare your p-value to level of significance. If your p-value is less than level of significance, then you have to reject what the null is. But if your p-value is greater, then you fail to reject what the null is. All right. So how do we find the p-value? Well, it's very simple. We use a norm distribution. Because remember, right, your result here is your z-value, right? And so what you're doing basically is you're trying to convert a z-value into a probability on your curve, right? So if you are dealing with a left tail test, right, then whatever you get as a p-value stays the same. So let's just assume that our z-value is 1.2, for example, right? Well, because this is to the left, let's say minus 1.2. Now, if this is a left tail test, you just say norm disk, right? Minus 1.2, 0, 1, true, right? And then you get a p-value, and that stays the same because it's the left, it's for the left, right? Remember, so p-value is left. Same way we did when we're doing the match distribution. Now, if it's a right tail test, you do 1 minus what? Norm disk. Minus 1.2, 0, 1, true. Well, in this case, it's probably going to be 1.2, right? But whatever the case, you do, if it's minus 1.2 or 1, doesn't matter, you do 1 minus because you're trying to look at it from what's the right side. And remember, your value is always going to give you to the left. So we have to do 1 minus to be able to find for the right side. Now, if it's a two-tail test, this is different. The two-tail test, what you tend to have is you have a value here and value here. And so this is going to be half of p, and this is half of p. Right? So pay attention here. This is where students get a little bit confused. Now, if it's a p-value, what happens is you're going to do your normal norm disk, right? You're going to do your normal norm disk. Let's say you do 1.2, 0, 1, true. Now, let's say you get a number like 0.3, right? Now, this value is for only one side, so it's only for this left side. So we have to find for the right side too. So in this case, you're going to say 2 times 0.3, that will give you 0.6, and that becomes the p-value. The problem here is, what if I have a p-value of 0.5 or 0.6? See, that would not work, because remember, this is a probability and it cannot be more than 1. So 0.6, if you have 0.6 multiplied by 2, that gives you 1 point something, right? That cannot work, right? And so if you have a scenario where you have 0.6, once the number is 0.5 or more, so in this case 0.6, the way we solve it, we say 1 minus 0.6, and that will be 0.4, multiplied by 2, that gives you 0.8. That becomes your p-value. Once you get your p-value, right, this is where we come to the end, because now you're going to compare your p-value to your alpha, right? Because remember, your alpha or your level of significance, that is, right, the maximum risk you're going to take. So if your p-value is greater than your alpha, right? So here we fail to reject it's a goal. If your p-value is less than or equal to alpha, we do what? We reject it's a goal. And remember, once you reject h sub o, then by default you are saying that you have enough evidence to basically accept h sub a, right? But if you fail to reject h sub o, that means that you don't have enough evidence to do that. So when you do the first one, if you fail to reject h sub o, you say we do not have sufficient evidence, right, to whatever the case is to reject h sub o. But if we do the other one, then we say we have, right? We have sufficient evidence to reject it. Now, critical value is actually the easier way to go, but it just depends on the student. Some students have told me they like p-value, right? And the reason with critical value is that critical value is a little bit different. With critical value, what that term means is it's a boundary, right? With critical value, it's a boundary. And what it's saying here is any number or any value outside this boundary will reject h sub o. It's clearly stated that, so it's easy for you to understand, right? So for example, we do the same example here. So let's say that you have a left tail test, right? And so with critical value, the same thing kind of process works. So you are giving your alpha. Let's assume that alpha was given is 0.01, right? That's the alpha that was given. And so what we'll do for p-value, for critical value, is we'll say, okay, you know what? Let's convert this value that we're giving, right? This percent, we're going to convert it to z value, right? And that's pretty easy. You guys already know that. So that would be your norm, right? Inverse. And so we'll do 0.01. And we'll do our 0, we'll do our 1. And let's say it gives us a number like, let's say minus 2.33, right? If that's the answer, what we're saying here is this is the critical value. This is where we're going to draw a line. And at that point, any value here, right, will be able to decide if it's going to be rejected or fail to reject. So I'll show you. So I'm going to draw this. And so our critical value is right here. So negative 2.33. Remember, these are z values, right? So this is our 0, right? Because that's our mean. What we're saying here is that if our test stat, remember our test stat is our z value for the sample, right? While 0 here is the z value for the population. What we're saying here is if you have a test stat, the test stat goes beyond negative 2.33, then it's too far for us to still accept what the company is saying. So let's say, for example, we have negative 3, right? Negative 3 is right here. Now remember, right, the same example we did. Remember, if Volvo said the car was 60 miles per gallon, and I said that it's 54 miles per gallon, let's assume that it's negative 3 for the test stat. What we're saying here is that this is so far apart that we have to reject what Volvo is saying, right? But how are we able to do that? Well, we're able to make that conclusion because of the critical value. The critical value creates a boundary and gives us a value and says that if your test stat, which is your z value from your sample, if it's further than this number, then it's too far apart for us to hold on to that company, to that company's statement. But if the result is close, let's say that it's right here, right? If this is what we had, then we can say that it's too close, right, to reject it. But if it's -3, we'll say, okay, since, right, the test stat
is in, because this area, this white area here is usually called the fail to reject area. And this black area here is called the reject interval. So we now say since T stat is in the rejection area, we reject interval, right? That's if we had -3. But if we had -1, we'll say that since the T stat is in the fail to reject area, we fail to reject interval. So you can see that the critical value has created a boundary for us to know how far we have gone to either reject or fail to reject. Now, that's if it's a left-tailed test. What if it's a right-tailed test? Right? What is a right-tailed test? And let's say we're going to use, let's say we tell alpha is 0.05. Right? Remember, if it's a right-tailed test, right, we're looking at this part. So 0.05 would not work for us, right? Because remember, this is a percent, this is 5%. And remember, this actually starts from almost at 0, right? And goes all the way to almost at 100. So 0.05 will definitely be on the left side. But we're trying to find for a right-tailed test. So we have to realize that, okay, what is the equivalent of 5% to the right side? And that will be what? 1 minus 0.05, which gives us what? 0.95, right? So that means that we have to look at this part, right? And so what is the critical value that represents the right side? Well, that's easy. That will be norm inverse. We'll put 0.95, 0, and 1. Let's assume that gives us 1.645, right? Let's assume that, which actually is what it's going to give us. So this becomes the boundary. So this becomes 1.645. This becomes a critical value, right? And then remember, this is a 0. So what it means now is that I need to take my test start and now compare that. Now, if I did my test start gave me a value like for the Z value, right? It gave me 3. You see, this area here is the fail to reject. Is O, but this shaded red area is the reject. Is O. It is, I know that because I found my critical value, which has created a boundary. And this boundary is telling me that any number that is more than 1.645 or more is going to be rejected. Not the number rejected, but will reject A sub O, just because it's so far. You can see we have 3. From 0 to 3 is about, it's so far, right? And so it's about 3 standard deviations away, right? So it's so far. So we will now say that, well, the answer we got was so far off from what the company is saying, so we have to reject what the company is saying, right? Now, if it falls here, then we fail to reject, right? So that's how the critical value works. Now, let's look at the third one. Supposing, and I'm going to create space here because we're running out of space. Now, supposing we have a two-tailed test, right? And this is where it gets to be, it's kind of fun, right? So two-tailed test, right? It's like this. So you got this. So what happens if we have a two-tailed test? Well, for a two-tailed test, let's assume that the alpha here is 0.05. Right? Now, remember, right, you got to look at this from a different perspective. If your alpha is 0.05, then technically what it means is, right, let me try and create some space here. I want this to make absolute sense. All right. So if your alpha is 0.05, right, then technically what you're saying here is that this is 95%, right? And so, but this is 2 sides. So that means that this side will be 2.5, and this is also what? 2.5, right? That's basically, that's what this is, right? We have this. And so this, it gives you a good idea of what you're dealing with, right? So you kind of understand what you're dealing with. Now, to solve this question, we do it very easy. We say, okay, All right. For the left side, it's going to be alpha over 2, which is 0.05 divided by 2, which will be 0.025, which we kind of know, right? Same thing as here, right? Because remember, this is percent, right? And then for the right side, it's going to be 1 minus 0.025, which is going to be 0.975, which we also knew, right? We knew that this part here will be 2.5%, and this part here will be 2.5 plus 95, which is what? 97.5. Remember, this is what we're dealing with, right? So 2.5 and 7.5. Same thing here, 2.5 and 7.25. Right? So these are the two sides. You're trying to create a critical value for the two sides, right? And so now that we've had this, so the next step now is to find a critical value. So we're going to do the non-inverse of the 2.5%, right? 0, 1. And then the non-inverse for the 0.975, 0, 1. And the results you're going to get are going to normally be similar, right? One will just be negative, one will just be positive. And so you have a negative critical value. And so some books will say negative CV and positive critical value, or some will say negative sub O and positive sub O. It's the same concept. So here will be negative 1.96, and here will be what? Positive 1.96. So those are the two extremes. What that means is if my test stat falls here, then we fail to reject A sub O. But if it falls here, then we reject A sub O. If it falls here, we reject A sub O. So let's assume that our test stats give us, let's say give us minus 2.6, right? Minus 2.6 is right here. So our test stat is minus 2.6. So we do what? We reject A sub O, right? But if our test stat gives us, let's say, I don't know, let's say 1, right? Because remember, this is 0 here. Then we now fail to reject A sub O. And once we fail to reject A sub O, then our conclusion is the same. Just the same conclusion we concluded here will be the same for both of them. So that's step 5. And then your explanation here is basically your step 6, right? Whether we reject or fail to reject is your decision making. And then we now say we have sufficient evidence or we do not have sufficient evidence. So I know that looking at this, right, taking it step by step and looking at the grand scheme, right, it looks like a lot. But once you understand the concept and you start solving questions, it actually is quite easy. And so what we're going to do in the next video is we're going to solve questions using hypothesis testing. And you're going to actually see that it's not as difficult as it is. It's actually pretty easy. Once you solve the first one, you're done. You're like, oh, okay, this is easy, right? Because you have an option of sometimes you have an option, like in the first part of the video, you're going to see you have an option of doing P values or critical value. But in the second step, we're going to stick with critical value. And so you can decide which one you feel more comfortable doing. But in the video, next video, I'm going to solve the question with the two methods, allowing you to choose which one you feel much more comfortable with. Now, I hope this video was clear enough and explained the concepts. But like I said, if this is still confusing, you can watch it over again. But also you can watch the next video where we actually solve real questions. Maybe that would make sense, because what I would do also is when I'm solving those questions, I will spend some time explaining that step 1, step 2, step 3, step 4, step 5, so you can see the steps being used to solve questions. I hope this video was very helpful, and please don't forget to watch the next video where we actually solve real questions, right? And this is also found in your module. So go to your module, pick the question, the Excel part of that topic, which would be solving questions involving where the population standard deviation is given And we're also going to do the next one is when the population standard deviation is not given. So before we go, just want to make sure I explain two key things. In solving hypothesis testing, we tend to use either Z values, and this is for test statistic. This is for test statistic, right? We tend to use Z values, what we call T values or T test. And I'll explain in more detail. Well, there are two key differences. In Z values, usually you're given a population standard deviation. In T values, you are not given a population standard deviation, or sometimes you're given a sample standard deviation. For Z values, you tend to have your sample size tend to be 30 or more, right? They tend to be that. And then your T values, you tend to have less than 30 values, right? But the most important key is the top one, right? That we use to solve these questions. And so you're going to do, in the first video, we're going to solve questions involving Z values where we have population standard deviation given and where the sample size is 30 or more. And then the next video we're going to do with T values where you're given a sample standard deviation, or you're not given a standard deviation at all, which you have to find yourself, and where the sample size is less than 30. All right. I hope this was very helpful to you. And I hope you were able to take some time to watch the next video that we're going to talk about solving questions with hypothesis testing. Thank you.